name is Ireti Ajala. I want to demonstrate what address matching or geocoding means for Nigerian markets. I've got an address here that I'll be using for this demonstration. Is in UK. I will be looking at pointing out the differences in the map data for UK held on Google Map and comparing that with Nigeria. And we'll be looking at the difference in intelligence really. The address I've got here is 1 London Road, is in Southampton. The postcode is SO152AE, which is this one. When you click search there, what Google Map does is simply interpolates the approximate location of that address, that complete address there, and which is this. Because it's number 1, you expect to find it right at the beginning of the road. You shouldn't expect to find it at the middle of the road, nor at the end of the road there. Now, when you compare that with what we have in Nigeria, we'll be trying to see if we can locate this address in Nigeria. 19 Simbiat Abiola Road is in Ikeja. Fantastic. That's very impressive, isn't it? What Google has done, Google has interpolated the approximate location of this address. However, there's a difference in the symbol used to mark this address in Lagos. This is just a circle with an A in it. The A means an address. When you compare that with the symbol used to map the location of this address in UK, you see it's quite different, isn't it? Yeah. So why is it different? Well, because the data used for UK on Google Map has got what we call geocoding intelligence, geocoding capability, whereas that of Nigeria doesn't have that. It's still the same road center map, but there are additional intelligence that Google has added to the UK data, which is not currently implemented on the Nigerian address there. So we will be looking at how one could easily do this for Nigeria. Now, what is geocoding? Geocoding is a process of assigning geographic coordinates to an address so that you can place it as a point on a map, and this is quite similar to putting pins on a paper map. This enables you to analyze that data with other spatial data. So, simply put, geocoding is all about address matching or assigning geographic coordinates to that original data. You don't do anything to it. You simply assign geographic data to that address. Now, the geographic data enables you to show that location or to mark that location on a map there. I have an address here that we will be looking at geocoding for Lagos. This is an address of businesses across Lagos there. You've got the address, it's a business actually. You've got the category there, which is basically high level classification based on what they do. And this is a professional service. They're into building and construction. The address is number 10 Kudirat Abiola. So this is the house number, that's the street name, that's the suburb. Kudirat Abiola is in Oregon. Now we have concatenated the house number with the street name into this address there, and that's what we have. This is the contact number, the email, and the website there. Now there are several of these addresses. Specifically, there are over 5,000 of them there. If we're going to map the location of each single address in the traditional way, we will probably need to visit every single address armed with a handheld GPS. You mark that location. Now, let's look at a little bit of finance here. There are about 5,000 records. So for you to visit each address, it will cost you, let's say it costs you like 100 naira to visit each address. So effectively you're looking at almost £500,000 just to mark the location of these 5,000 addresses. That's a huge cost. With that money, you could buy a nice, clean looking Tokumbo with that money. But there are other ways of doing this. The thing about GIS is it enables you to work smarter and more intelligently. GIS doesn't, provide a magical way of solving problems. What it simply does is enables you to look holistically at a problem and prefer an intelligent and a smart solution to that problem. So instead of having to physically visit each address, we will sit down right in the comfort of our office or sitting room, as I'm doing here, and we should be able to mark the location of that address within a certain level of confidence there. The position accuracy of this actually that is dependent on the accuracy of your reference data. What do I mean by reference data? Now, for you to geocode an address, you will need a reference data. Your reference data is basically centerline street map of the city. For instance, this is my center line. I'm going to show the street name of this so that you can see is actually down to street level, and it covers everywhere in Lagos actually. If we turn off the road label, you can see the extent of this data that we'll be using for our geocoding. Apapa down to Epe there. You have Ikorodu somewhere there. This is just for the purpose of this geocoding, really, for this demonstration. Now, what we have also done is to bring in the same address data into MapInfo. I'm using MapInfo, by the way. You can use S3 ArcGIS or any other GIS software for this. Having done this, this is the address there. We haven't done anything to it. We have simply brought it in its natural format in Excel into MapInfo, and that is it there. So this is what we'll be using for geocoding. You will need what we call a reference data. The reference data or the base map is this is what you get from the base map. For every single street, we have provided a town or a suburb there. What it simply does is it helps us to uniquely identify a street. Why is this important? So that you can completely remove incidents of duplications, errors, and sometimes here is one problem you could actually face if you haven't done that. Here is Yusuf Street. There are 1, 2, 3, 4, 5, 6, 7 streets called Yusuf Street, and they're different parts of Lagos. This one is in Ikpaja. That one is in Ojo. The same Yusuf Street is in Olode Apapa. You also have Yusuf Street in Mushin, and there's Yusuf Street in Ikpaja. So if somebody gives you an address in Lagos, say number 15 Yusuf Street, it still hasn't told you anything, because you want to know Yusuf Street where? Yusuf Street Mushin, Yusuf Street Olode Apapa, Yusuf Street Ikpaja. And one thing that could actually help to remove this kind of duplication is postcode. When you have postcode, postcode simply groups addresses within a specific area into one. Well, interestingly, NIPOS has postcode for Nigeria, but I don't have much confidence in the accuracy of that data. Why did I say that? On NIPOS data, on NIPOS and postcode data, it simply gave the same postcode to Surulere and Ikeja. This is Ikeja here. How far are these apart? Let's see if we can zoom out there. If we're going to measure that as a crow flies, we are effectively looking at Ikeja to Surulere. Take a look at that, almost 12 kilometers apart. within that corridor, there could be as many as, say, 400,000 addresses. That's almost half of Lagos. So if NIPO says the address in Ikeja and the address in Surulere share the same postcode, it doesn't make sense to me. So I have been able to get around this by providing a suburb for every single address, and I'll show you why this is important when we start geocoding address now. To geocode this address file we're bringing in, we will go to our menu, pick geocode option there. Now, I'm going to take you through these options. I'm going to take you through how to use this. The first thing we do is we select the address we want to geocode. We leave the address we're geocoding is the column we'll be geocoding is the address there, which is that. Now, here is where we select the base map, our reference data. We're using the street for that. Now, we need what they call a boundary data. The boundary data is the one I created that shows the extent of each suburb across Lagos there, and I will be picking that. We're going to give this a symbol. Let's give this I love blue cuboid there. Now, having done that, let's go to the option. The option will be displaying the address, we'll be displaying the suburb in addition to that, and we're going to leave that. Now, you need what they call an address substitution file. Why is this important? People have different ways of writing, of abbreviating a street. Some will write a street as, STRAAT. Other people will abbreviate that to ST. So other people abbreviate it to STR road. Some abbreviate it to RD. Some abbreviate it to ROD. Close is abbreviated to CL. Some places, sometimes, you have different street types with different abbreviations. So these abbreviations are actually stored in this file with MapInfo. You need to take a look at it, and if there's a particular abbreviation you'll be using that is not there, then you probably need to add that to it. Now, we'll be using this option. The closest address is what we'll be using to mark the location there, and we'll be using data from the boundary to uniquely identify each address there. So having done that, now we are going to attempt to geocode the entire file in one go, and that is the automatic mode there. So we have done that. Now you watch it there. So MapInfo will try and pick each address, match it there using the reference file, and you can see the status there. 171 has been matched out of 3,863, and that keeps going there. So what that means is MapInfo has successfully geocoded 248 and 5,302 are not accurately geocoded. Now, before we go to evaluating this address, let's see if we can display it on the map now. This is it. Good. So that's the address we'll be geocoding. We have successfully geocoded there. If you turn on the street name, it makes it a lot easier for using it. For instance, this one is Ilupeju bypass. Oh, fantastic. That's Ilupeju bypass. See, MapInfo has successfully geocoded it there with the house number. Now, there are two addresses there. You see, this one is number 5, Ilupeju bypass. You see, MapInfo had interpolated the location of that address closer to the edge. You should expect that, number 5. You shouldn't expect number 5 to be right at the middle, the same place as this there. So that gives an idea that this has been quite successful. Now, let's go to Symbiat Abiola to see if we have been able to do that, which is this. Symbiat Abiola, let's see what we've got there. That's number 22, Symbiat Abiola. That's 19. Oh, fantastic. So this is 19 there, and that's 17. So this is fantastic. 17 is on the same side as 19, whereas 22 is on the other side. So what MapInfo has done is locate all the odd numbers on the left of the road and all the even numbers on the right of the road. That is intelligence. So we have been saved the stress and the cost of physically visiting this place there. Now let's see what happened to those other ones that were not able to geocode. To do that, we will be, let's go to our geocoding window again. We'll be using the address here instead of the street, and instead of the automatic mode, we will select the interactive here. Now, having done that, we will need to put the suburb there. So number 15 Adeola Odeku Street is in VI, which is in the reference data is actually there. It is Adeola Odeku Street in Victoria Island. So why didn't you code it? I'm suspecting the problem could be in the street type, in the road type. Look at this one is case sensitive. That's lowercase s, and that's uppercase s. I am thinking that could be the problem. Whatever the problem is, we select this. Now we go to Umara Bass Close. We seem not to have that in our reference data. It doesn't make any difference. We simply ignore that. Then the next address is 22 Idowu Taylor Street in VI, which is that. We select this. Agbaribo Close, that's another one. This one is in Allen. Agbaribo Close, that is it there. We pick it. Kujore Street is in Ilupeju, which is that. We pick that. Idejo Street is in Victoria Island, which is this. Town Planning Way is in Ilupeju, and that's that. So now we will be working our way around this. Now let's stop there so far. So now we have been able to add 12 additional addresses successfully geocoded on this address there. So that is what address geocoding is all about. Now, how useful could this be? Address geocoding is very, very useful in different ways. For instance, one of the problems I think that is very crucial, very critical to planning the electricity consumption for Nigeria is not knowing the average unit address consumption per address. All right. Now, for instance, one could say, okay, what's capacity of transformer should we provide, say, for Surulere, for instance? It's going to be quite difficult for us to accurately work out that solution if we do not know how many houses are there and what is the average utilization of each address. Once we have this, that will give us that capability to effectively and optimally plan the electricity utilization for that area. All you simply need to do is, if we can geocode every single address in that place there, then we can work out what is the unit usage for each address. By the time you add up this, that will give us an idea of the estimated usage for that particular area, and you can now pick the optimum transformer capacity for that location instead of underutilizing the transformer or overutilizing it. It's not just enough to pump money into distribution or into electricity generation. We need to sit down with intelligent data to plan how to supply each house there. The electricity company in UK, they use and depend heavily on address data matching before they can actually supply electricity for that area. In UK, they can, if you give them an address, they know what has been your average use over a period of time. So that is one. Then again, the recent seamless registration database. I thought that's fantastic. But we could add more value to that database. What do I mean? That database contains the name of an individual, the address of that subscriber, the area where that subscriber is living, and a lot of other information about that subscriber. Now, interestingly, this is the best citizen database available there. If we can use this database judiciously and add geocoding capability, we can use it for so many things. For instance, you could use it to plan, say, school enrollment, to plan access to quality health service. You can use it to plan so many things there. Infrastructure, because we have an idea of how many houses are in this area. So this could be useful in several areas to the government. The private companies too could also have a great use for this. Banks, for instance, they want to know the geographic spread of their customers, or insurance companies want to know the geographic spread of people who took a particular insurance policy. It could be Mr. Biggs want to know the geographic spread of people who come to their restaurants. It could be